I need to record the session. In our last lecture, we have discussed about AdaBoost classifier. And in AdaBoost classifier, we have seen one of the algorithm for AdaBoost algorithm. Okay? It is classification algorithm. And in that case, in AdaBoost, we have developed several stumps, if you can remember that, several stumps. And each and every stumps has some weight of the vote. And then that weight of the vote, finally, we utilize that. For classification purpose. Okay? Like last class we have discussed about uh, construction of three stumps. We have constructed just the outlook. Okay, this system, and then we also assume that maybe based on the data set we can got uh, two other stumps like humidity and temperature. Okay, these are the stumps. Then and then using those or utilizing those stumps, we have finally decided the class levels of unknown, that is unseen instances. The AdaBoost classifier is improved in some ways. Okay, uh, the improved version at AdaBoost is called the gradient boosting. Okay, the gradient boosting. And now today's lecture we will discuss about the gradient boosting, specifically gradient boosting regressor and gradient boosting classifier. Uh, we know that the gradient boosting is also upgraded, and then the new version of gradient boosting is called extreme gradient boosting. Okay, so we need to understand gradient boosting to understand the extreme gradient boosting. In our today's lecture, we will discuss about the gradient boosting. Okay, for that one of the game we can discuss about, like if you are given the data points x1, y1, x2, y2, xn, yn. So these are the data points, and we know that there is x1, y1, x2, y2. Specifically, the x1, x2, and xn. Those are our feature vectors, and y1, y2, and yn. Those are our class levels. Those are our class levels. Okay, so the x1, x2, and xn, those are our uh, feature vector or feature values, and y1, y2, and yn, those are our class levels. Okay? Class levels. Like in our last class of AdaBoost, we consider that this is our data set. So these are our features, and here is the this is a decision variable. Okay, so we can say this is our x1. This is our x1. That means feature values of instance 1, and this is the y1. Okay, this is the y1. This is the y1. Similarly, the x2. This is our x2. There is the feature values of our second feature, second instance x2, and this is our y2. So y2. So here is also the same, that like a data set. A data set is given x1, x2 up to xn, and the task is to fit a model f of x to minimize some of the loss function. Maybe the some of the square residue also. Okay, some of the square residue. This loss function. If we can think about this loss function, that means you are given a data set, and then you want to build a model, uh, fit a model f of x to minimize the loss function. That means minimize the error. Now, suppose your friend wants to help you and gives you a model f. So that means you want to select the perfect model. You want to select the perfect model. So that your friends want to help you and gives you a model f. Uh, you check his model and find the model is good but not perfect. It means that the model your friend gave, we can say that there is the model you already have. That model is not perfect. It has some sort of error. Okay, some sort of errors. Um, for example, like the f of x, there are some mistakes. Like f of x is 0.8. That means the provided model predict if the input is x1, that is, if the feature values, if we input the feature values of the x1, then it will provide you the prediction result is 0.8. But the originally the y1 is 0.9. So that means there are some differences. Okay, the original value is 0.9. The model you have, the prediction is 0.8. So that means there are some errors. So there are some errors. Directly, if we can subtract that, then this error is 0.1. 0.1. So there are some errors. Like if input is x2, the model will provide the 1.4. This is the prediction of that model. But originally, the model output model is 1.3. Okay, so that means there are some errors on your model. Then the question is, how can you improve this model? Is there any way to improve this model? Yes, there are several ways, but there is a rule for the game, is you are not allowed to remove anything from f or change any parameter in f. Okay, so that means the model given f, you need to keep it as it is. So that means f is fixed. Then how can we improve the performance of that model? So that's the question here. Okay, that's the game here. That is, the model f is fixed, and then you need to improve it. Then how can we do that? Okay, so that is actually in gradient boosting. What we usually do. It's an additive model. It means that the f is fixed, then what we can do, we can determine the errors. We determine the errors for each and every input. And based on the errors, that means based on the errors we have, uh, we can develop maybe another model like this H. We can develop the model H on the errors. Okay? And maybe F plus H will give you the correct answer. Okay? Correct answer. So it means that you can just add additional model. Let's say that if the problem is regression, then apply the regression tree again on H to F. What's H? H is actually our build on our errors. Okay, errors. So the new prediction will be f of x plus h of x. So that means this h of x we will build on the errors, on the differences from the original minus prediction. Okay, original minus prediction. It means that f of x1 plus h of x1 will provide us the y1. F of x2, whatever the result from here, h of x2 will provide us the y2. Okay, like here in this case, we can say f of x1 is 0.8. If this one provides us the 0.8, and if the new model, that is h of x1, this model is built on the errors, and if it will provide us like 0.1, and then if we sum up these two, then it is 0.9, which is our y1, okay. Similarly, f of x2, maybe it will return other value, like here it is returned 1.4, it is written 1.4, so this is 1.4, and the new model is of h of s2, it will maybe return just 0.1, then we will get the 1.3, okay. If we can say there is 1.4, and then if it returns as negative 0.1, then we will get 1.3 here. Okay. 1.3. Yes. Okay. Now, so that means we can build maybe just one model. But what uh, if just only we build another model that will also predict, the accuracy of the prediction is also maybe not good, or we can say still there are some errors. Then what we can do again, we can build up maybe another model like f of x1, and then if we consider about h of x1, uh, and also the h of x2, sorry, h of x1, another one. You can say this one is h1 of x1, and this is the h2 of x2. Okay, it means uh, till we can get the minimum error, we have to add the models. Then we have to add the models. First one is the given one, and then this one is based on the errors of the first one, and the second one is based on the errors of second one. Okay, in this way, we can maybe construct many other models to get our original value y1. So that is actually gradient boosting. It will do like this way. But in AdaBoost also we have done the similar fashion, but a little bit different way. That means if we consider that this one is our weak classifier, it has some error, and based on the errors, we have to develop this one. This is also another weak classifier, and then based on this weak classification, we can maybe build another one. Like this way, we have also built similar fashion in AdaBoost, but the gradient boosting is a little bit different from the AdaBoost. So if we can see that it's f of x1 plus h of x1 equals y1, then what we can write? We can write the h of x1. It is y1 minus of f of x1. Okay, y1 minus of f of x1, and that's what we have already calculated. Like if this is the original value 0.9, and this is the prediction one, so 0.8, then h of x1, it will be the negative, the subtraction between these two, it is 0.1. Okay. Similarly, we will get the h of x2 up to h of xn also. Actually, this is the error, and we will consider this error to build our new models. Okay, so that means the residual. Now, how it is different from our AdaBoost? Okay? How it is different from the AdaBoost? We want to discuss a little about that. In case of gradient boosting, we need to apply the gradient descent plus boosting. Okay? Gradient descent plus boosting. Where we can apply the gradient descent, and boosting is actually the same as our AdaBoost. So this is gradient boosting is an additive model, fit an additive model, that is an ensemble model. So this is, we can say h of x, and then this is rho of t, specifically this one. Usually, sometimes we need the weight. So like in AdaBoost, we have already calculated the alpha. Alpha, that is the amount of, say, or the weight of the vote of each and every weak classifier. Here is also rho is the same kind of thing. The weight of the vote. Okay. Here is in each stage, introduce a weak learner and compensate the shortcomings of existing weak learner, as I already mentioned that. Yeah. But in AdaBoost, we can see that the shortcomings are identified by high weight data points. In our previous lecture, I have already mentioned that there is um, we need to find out the misclassified instances, and then the misclassified instances, the weight of the misclassified instances, we need to increase to pay more attention to those misclassified instances. So that means in case of AdaBoost, we need to find out the misclassified instances. So those are erroneous. And then we need to increase the weights to pay more attention to the misclassified instances, so that maybe in next iteration, or if we can build the next weak learner, uh, those can maybe get the higher priority. Okay, and we have seen that is exactly it works fine for AdaBoost. But here is the difference between AdaBoost and gradient boosting. In gradient boosting, the shortcomings are identified by the gradient. Okay, by the gradients. Instead of the identified shortcomings, we have identified and then increase the weights. So in case of the AdaBoost, the same thing it will do. The gradients will do the same thing. Okay, the gradients. So we will determine the gradients, and then gradients will do the same thing. Okay. Uh, so both high weight data points and gradients tell us how to improve our model. That means based on the gradients, uh, it will pay the attention to the misclassified instances, like our pay more attention to the high weight data points. So how can we apply the gradients here? Okay, how can we apply the gradients here? And we know that the uh, for the gradient descent, we have already discussed maybe in our second lecture or maybe first lecture about the gradient descent. So I think you know that here is the equation of gradient descent. Okay, like uh, we can see that the update of parameters. If we want to find out the optimal value of theta, then what we have to do, we have to uh, take the derivative of the loss function here. This is j is a loss function, derivative of the loss function with respect to there is theta. And then this is our gradient. Okay, so it will provide us the gradient, and then the function will move, or we can say the weight will update based on the gradients. Here you can see there is the previous value minus of here the rho times the gradients. Okay, rho is the learning rate times our gradient. Uh, so at first we determine the step size, and then maybe then we have to update the variable values using this equation. Okay, the same equation here. The previous one minus the previous value minus of the gradient times learning rate. That is the step size. Okay, and we can see there is specifically the function by moving the opposite direction of gradient. So that means if gradient is positive in this case, you can say if gradient is positive, then actually it will decrease the values of y. If the gradient is negative, then it will increase the values of y. Okay, so that is the opposite direction. Uh, so in gradient descent. Uh, now we want to find out this gradient here. This gradient, we want to calculate this gradient, but in gradient boosting, some of the loss functions will give us the very simple gradients. Okay, very simple gradients. And what are those? Specifically, if we think about our residual, okay, the residual residual is what? Residual is actually the original value minus the predicted value. This is the residual. Okay, this is the residual, and we know that there is the sum of square residuals. So that means this is the residual, then square that. So this is the square residuals, and we have to sum up for all the originals and all the predictions. Okay, for all the originals and all the predictions. That is for uh, this is our sum of square residuals. But here, if we introduce some of the residual, that is called pseudo residual. Okay, pseudo residual. On that case, maybe we have to sum up the residuals. But here we can see not only this. If we can think about the pseudo residual, just divided by two. Okay, divided by two. So this is not actual residual. Just we divide it by two. So that's why it is called the pseudo residual. Okay, pseudo residual. If we consider that our loss function is a pseudo residual loss function, why we divide by two? Because it will provide us the mathematical benefit. Okay, so that's why we have divided this one by two. So you will see the mathematical benefit. Okay, why we divide it by two? Why we make it pseudo? So if we consider this is a loss function, where we can see this is a loss function here, j is a loss function. This one is the ly of f of x, and our specifically we apply our loss function y equal f of x squared divided by 2. Okay, and if we take the derivative of this loss function with respect to the f of x, that means we can see the f of x is uh, our parameter to optimize, or parameter to change. Uh, but y is the fixed. Okay, so we cannot change the y. So that's why we have taken the derivative with respect to f of x. Then if we take the derivative of this equation with respect to f of x, then what we will get? Uh, we will get like d of L by, how is this? Wait, yeah. So consider this is our j. Okay, j loss function. So d of j delta j by delta f of xi. So it is same as the delta of summation of L of yi and f of xi divided by the del f of xi, and that is the del L this one and f of x this one. But now we can see if we take the derivative, then the equation will be, if we take the derivative, so here is y minus f of x. This is the prediction and this is the original value, x squared divided by 2. Okay, so if we consider this is our j, and we are taking derivative with respect to f of x, and then what we will get, the half, so we can say half will be there, and for this part what we will get, that is y minus f of x square. So the term is square, that means 2 will come here, and then y minus f of x. Okay, using the chain derivative principle, we can see this part, we have to take the derivative of this part again, because this is not purely x but y minus f of x square. So what we can do, we have to take the derivative of this part again, then y is 0, and then f of x is, we are taking derivative with respect to f of x, so this will be 1. Okay, so actually we will get what? We will get, here is a 2 and 2 cancelled out, then we will get the negative y minus f of x. Y minus f of x. Okay, what is it? You can see y minus f of x. This is the prediction. This is the original. So what we can write? We can write that this is actually, this part is actually, this is our residual. Okay, residual. Okay. So it means that the gradient is actually the negative of residual. Okay, negative of residual. So we can calculate the residual easily. Okay, that means the y, the original value minus the f of x, the predicted value. You can calculate the predicted value and then subtract from the original value. Then we will get the residual. So if we negate it, if we just negate the residual, then we will get the gradient. It means that it is easy to get the gradients. Okay, easy to get the gradient. That is the negative of the residual is the gradient here. Okay, so that's why. But in that case, we have to apply the pseudo residual, not just only the residual, because the residual divided by 2. So that's what here we have mentioned here. Okay, we can interpret residual as the negative gradient. The residual as the negative of gradient. Okay. Uh, So now, if we can just make it similar, just put the value here in this equation. So previously we have written like f of x equal the f of x plus of h of x. Okay, so that means we can see the updated value of our this one, it will be the previous value plus of the new model, the prediction from the new model h of x. The prediction from the new model h of x, previously we have seen that it is actually this one. This one is what? This one is yi minus of f of x1. If you can remember this here. H of x1 is y1 minus of f of x1. That is h of I equal yi minus of f of xi. Okay. So that's why we can write it, instead of this one, we can write the yi minus of f of xi. Okay. We can write this one instead of this one. yi minus f of xi. And yi minus f of xi, we have already got what? We have already got this. There is this. There is y minus f of x. This is actually the negative of del j divided by f of x. Okay, so that is the gradient. So we can put the value here. So this is yi minus of f of xi. Actually, it is our gradient with respect to the loss function j. Okay, and the negative of that. Negative of that. But this time we assume that the row is 1. Okay, row is 1, just row is 1. But we can control this update by the learning parameter also. That's why we can introduce uh, instead of 1 this row here. Instead of 1, we can introduce the row here. The row. Okay. That is similar to our gradient descent updates. That is the new value. It will updated from the old value minus of the row times the gradients. Okay, row times the gradient. Row is our learning rate and gradient whatever we got from our loss function. Okay, so that's why we can see that actually what we need to do here, we need to calculate the gradient. We need to calculate the residual. The negative residual actually that is the same as our gradient. So we will it will update the same way as our gradient descent. Okay, then finally what we can write for this case, start with an initial model for the gradient boosting. Start with an initial model. Let's say f of x. Okay, that is in our game example, we assume that one of my friend given that model. Okay, that means that model we have. This is the very basic model f of x. We can see here we can build up such a model like just averaging the values. Okay. Uh, so for the regression problem, if we apply just the averaging method, there is sum of all the y values divided by n, and then it will provide us the initial model. Okay, the average is very simple, very simple prediction. Okay? So that can considered as our initial. So here the average, this one is considered as our initial model, and iterate until converge. Okay? Then what we have to do, calculate the negative gradients. Then how to calculate the negative gradients? We know that how to calculate the negative gradients. Negative gradients is same as our residuals. Okay, residuals. So we need to just calculate the residuals, specifically the pseudo residual, and then fit a regression tree H to the negative gradients. Okay, so that means whatever we got the residuals, uh, we have to build a regression tree H. That is a new model H. We have to build a new model that is H. So if we build a new model that is H, then what we have to do, build a new model H, and then update the model based on the new model. And here we can see there is the f is our previous value times h is our new value, and here is the row. Row is our learning rate. You can consider learning rate equal 1. Actually, this is uh, not practiced. The row must be some values like 0.01 or 0.001 like this. Okay. So in this way, we have to update our models, additive models. Okay. So that's what the gradient boosting. So this is the algorithm of gradient boosting. Gradient boosting. Uh, okay, so though this is the algorithm of gradient boosting, but this is many things abstract here. So I think to understand it more clearly, we need to I need to explain with example also, and that's why maybe I want to go for the example to explain this algorithm. And I have the lecture sheet for that. Okay, so gradient boosting for regression. Now, if we have a data set like this one is a data set. I think previously you have seen this data set, maybe, don't know. So this data set is about the prediction of the IQ score. Okay, so this is a regression problem. We want to predict the IQ score. IQ score can be any fractional values also, like 3.5, 5.6, 60.1, like this way. Okay. Uh, so here's the normalized IQ score. Let's say this is the normalized IQ score, and then place of based on what? Based on two features. One is age, and another one is place of living. And based on these two features, we want to predict the IQ score. Okay? And for that, we have taken a data set of 6 instances, 6 observations we have, or you can say 6 persons we have. The first person or first individual, the age is 8 and place of living is village, then IQ score recorded is 1. And then age is 10, place of living is city, the recorded IQ score is 3. And then age 12, place of living is village, the recorded IQ score is 1, like this way, okay? Like this way. Then we have a data set. Now again, the gradient boosting regressor is one of the nonlinear regressor, okay? Nonlinear regressor. Uh, uh, so if we can see that it's age versus IQ score, just only age versus IQ score. And even though we have a very simple that the small data set, and we can see that just on the linear regression, any kind of linear regression is maybe not perfect for this data set, because we can see we have some observations in the other side also. Okay? So that means for this kind of data set, the nonlinear regression will be better. Like the gradient boosting is a nonlinear regressor. Now what we have to do, this is a regression problem, then what what we need to consider? Consider that is we need to consider our feature field. So that means we have two features, age and place of living. Think about the age. In tree-based regression and classification problem, we can see that is the handling numeric values is different than handling our categorical variable values. Okay, so we can see here the age, those are numeric values. The numeric values, that is 8, 10, 12, 30, 35, and 60. So those are the numeric values. So we have to deal with those numeric values differently uh, from the place of living, because those are categorical variable values. So how can we deal with the age variables? And we have to keep in mind that this is a regression problem. So age, these are the age and place of living is given. The IQ score, these are the IQ score, and we know that in case of gradient boosting, or for regression, or maybe for classification problem, what we need a base model. Okay, that is we have discussed here. That is start with the initial model, that is the base model f of x, and we have developed, or we have calculated this f of x by summing up the value divided by n. Okay, summing up the value divided by n. So we can see that is the sum of the y values divided by n, then it will give us the prediction model, that is initial model we have. So now we can, if we consider about the IQ score, so all these IQ scores we have 1, 3, 1, 4, 5, and 2. Then we have to sum up all those IQ scores, like 1 plus 3 plus 1 plus 4 plus 5 plus 2, and then divide by 6. Then we will get the average IQ score. Okay, the average IQ score will be 2.667. So this is our f of x. So this is our f of x. So f of x will be 2.66 or 67. Okay, so we have to consider this is our base model. And after finding out the base model, what we have to do, the next thing is we have to find out the pseudo residual, because we know that pseudo residual is our the gradients. Okay, the gradients. So that's why the residual we need to find out. We can see here the average IQ score. This one is average IQ score, and original IQ score. These are our original IQ scores. How can we find out the pseudo residual? it will be 1 minus, so that means this is original minus the prediction. What is the prediction? Prediction is 2.67. Okay, prediction is 2.67. Then what we will get? We will get the negative 1.67. Okay, negative 1.67. So this will be for the first case, for the first observation. And for the second observation, what we will get? We will get that is the 3 minus 2.67. 2.67, 3 minus 2.67 is it is 0.33. Okay, 0.33. So 0.33. So here is this. This is 0.33. Okay. So in this way, for all the observations up to 6, we have to calculate the pseudo residuals. Okay, these are our residuals. Okay. Now, now what we have to do? Uh, we need to find out the h of x. Okay, we want to find out now h of x. But h of x, we need to build the h of x based on these errors. Okay, based on these errors. Based on these errors, we need to find out those based on these errors. So what we have now, we can see there is this h of x is another model. Okay, another model, another weak classifier, another weak classifier. But how can we find out that weak classifier? And again, as we have discussed in the game, that is, we have to keep the f of x fixed. Then this one will be the additive model. So this additive model we will build based on the errors. Okay, this on the errors. So these are the errors. So these are the errors. So that means the AS8 place of living is this one, and our pseudo residual. These are the pseudo residual values. So these are our pseudo residual values. We need to consider this is our data set. And from this data set, we will find out h of x. Okay. So now how can we do that? Again, the is this one. We can see we have the numeric values. So we know how to deal with the numeric values from the discussion we have discussed in random forest, and then we have discussed maybe the regression tree and also under boost. Okay. Uh, so that means at first we need to sort the data set based on in ascending order of age. So luckily we can see it is already sorted because 8, 10, 12, 30, 35, and 60. So those are already sorted. Those values are sorted. So that's our bonus here. So that means it is already sorted. So the next thing is what we have to do. We have to find out the middle value or average of two consecutive numbers. Average of two consecutive numbers like 8 and 10. The average will be 9, and then 10 and 12. Average will be 11. Like this way. Okay, so we have to find out the average of consecutive numbers, and here is this. The average of these consecutive numbers is 9. Average of these consecutive two numbers, those are 11. Average of these values are 47.5. Okay, so those are the average value. Now what we have to do, so if we consider those are the average values, okay, those are the average values, we can consider that there is the 9, 11, 21, 32.5, and 47.5. Each and every average value as our splitter, and we need to find out where to split or which splitter we should use if we consider the edge feature. And for that, we have to apply, we have to consider each and every average and find out the errors. Okay, which of the splitter will provide us the lowest error, and that will be considered as our edge feature. Like these are the values, and if we consider S9 as the separator, S9 as the separator, so that means if we consider S9, so age less than equal or maybe less than 9, you can consider less than equal also, age less than 9, and then what we will get? So age less than 9, for these observations, maybe this is the true, some of the case it is false. So then you can see there is for the first observation, the observation number 1, the age is 8. If we pass this observation here, first observation here, then actually 8 is less than 9. This is true. Okay. So observation 1 we have to place in the true side. And then the next observation, that observation 2, the age is 10. 10 less than 9. Is it true? No, it is false. So that means you can see observation 2 we have to place in false side. Then observation 3, age is 12. You have to place it is in false side. Similarly, observation 4 must be placed in false side. 5 also here, and 6 also there. Okay. Now what we have to do, so the corresponding pseudo-residual values we have to consider. Like for this one, the corresponding pseudo-residual value is negative 1.67. As I have already mentioned that actually this is our data set now. So that means the pseudo-residual, this is our the IQ score, or we need to predict that one. Okay. So the negative 1.61. Then for the observation 2, the next one, this one is 0.33, 0.33, 0.33. And the next one, that is the 3. For the 3, it is negative 1.61. So it is negative 1.61, 67. And for the 4, it is 1.33, 1.33. And for the 5, it is 2.33. Okay, 2.33. And for the 6, it is negative 0.67, negative 0.67. Okay, now what we have to do, we have to find out the average of our true side instances and false side instances. Here, in this case, we can see true. This side, this is the left side of mine. So this is actually, we can consider this is the left side. This is the left side of the tree, and this is our right side of the tree. Okay. So we have to find out the average of left side. You can see that the average PR to receive the score of left side instances, and we have just only one instance. If we just find out the average of that, and 1 minus 67, you can see 1 minus 67 is there. Okay? And we have to find out the average of right side instances. That means these are the instances we have. We have to find out the average of those. So sum up and then divide by 1, 2, 3, 4, 5, 5. Okay, 5. Then you will get the average PR score of right side instances. You will get 0.33. Okay, 0.33. Now what we have to do, we have to find out the sum of square residual, by 2. Why this one? Because that's what the pseudo residual will get. Sum of square residual by 2. Sum of square residual by 2, that means on that case, how can we find out the sum of square residual by 2? In this case, we can see the, that is the left side instance. So this is the left side instance, and this is the right side instance. The average of left side is negative 1.67. Average of right side is 0.33. 0.33. So that means we will consider that those are our predictions. For the left side, the prediction is negative 1.67, and for the right side, the prediction is 0.33. Now, if we consider those are our predictions, then we have some actual residual. Okay, so the actual residual is this. So that means if we can consider SSR, if you want to find out the SSR, the actual residual is negative 1.67. So negative 1.67 and minus the prediction. The prediction is negative 1.67. The prediction is also negative 1.67. 67. So this is original minus prediction. So original is this one, this value is the original value, and minus this is the predicted value. And then square of that. Okay, square of that. And for the next observation, observation 2 to 5, 2 to 6, those will be in false side or right side. And for that, the original is, you can see here, it is 0.33. This is the original. 0.33 is our original. And minus, so prediction is what? Prediction is also 0.33. Okay, 0.33 for the second observation. The square of that plus. And then the third one is negative 1.67. So here is negative 1.67 and minus of what? Minus of the prediction. Prediction is 0.33. 0.33. Then a square of that plus. Then the next one, that is fourth observation. It is 1.33. 1.33 minus prediction is 0.33. 0.33 whole square plus. And then fifth one is 2.33. 2.33 minus 0.33 whole square plus the negative 0.67. 0.67 minus minus what? Minus 0.33. 0.33. Okay. Uh, so that is our SSR. Then we have to divide this, the whole things, this one by 2 to get the sum of square residuals by 2. Okay, to get the sum of square residual by 2. If we do the math, then you will get here 5. Okay, you will get the 5. Similarly, we have to consider is 11, like the same way, that is less than 9. We have to do the same way, like is less than 11. And again, what we will get? The true and false, the true side and false side. And some of the instances we'll get here, and some of the instances we'll get here. Like this time, A is the separator. So the first observation, age is 8. So this is true. So the first observation we need to put here. Then the second observation, it is the age is 10. That means second observation, this is also true. So second observation will be here. And for the third observation, the age is 12. So it is false. Okay, so 3 will be there. Fourth observation, the age is 30. So that means 4 will be there. And 5 will be here. And 5 will be there. Okay. 6. Okay. So that means now again we have to find out the average of left side instances and average of right side instances. Okay. And in this way we can find out the sum of square residuals. Okay. And this time we will get 6. Similarly, we have to consider 21 as the separator, then 32.5 as the separator, 47.5 as the separator, and we have to find out the corresponding sum of residual by 2. Okay, so these will be the sum of square residual by 2. Now we have to find out this is the one of the error. Okay, so that means which of the splitter produce the lowest error. We need to find out that, and we can see that the lowest error here is 3.67. So this is the lowest error, and this lowest error induced by the splitter is 21. Is 21. So that means if we consider the age feature in our data set, we have two features. If we consider age feature, then we have to think the splitter as is less than 21. This one we have to consider. Okay, have to consider this one. Okay, but the thing is, in our dataset, we have also another feature that is called place of living. And now we have to work on the place of living and then compare the surface residual or error produced by S and error produced by that is place of living. And then we have to find out which one is minimum, which one induced the minimum error. Okay. So that's why the place of living we need to consider. But we can see that place of living is categorical feature values. So it's easy to that is deal with the categorical. So now the place of living and the pseudo residual, corresponding pseudo residual from our data set, from this data set, okay, from this data set. That means you have to consider this part only here, this part only, uh, place of living and the pseudo residual, okay. So here is this. Now we can see that is what will be our possible splitter in this case. The place of living, so those are the, we can see just two types we have. One is village and another one is city, two types. Uh, then we have to think about our, that is splitters here. The splitters can be like, if we consider if place of living, that is place of living equal village, okay, equal village. If this one is our splitter, then again it will split our data set into two part. One is true and another one is false. So in true side and false side, we can see this is our observation number 1, and this is 2, this is 3, and this is 4, then 5, then 6. So those are our observations. So village, the first observation that is the village. Okay, place of living equal village. A first observation, yes. So we have to place in true side, 1 in true side. Then for the second observation, it is city. Place of living is village, no. So that means we have to place the 2 here in right side. Then 3, it is village. Okay, so that means we have to place it in 3. And then 4 is also village, so you have to place the 4 here. And then 5, it is city, so we have to place 5 here. And 6 is also city, so here. So those are the observations. And now we have to think about the corresponding residual. That is, for the 1, the residual is negative 1.67. And for the 3, it is 0.33. No, for the 3, it is negative 1.67. And for the 4, it is 1.33. And for the 2, it is 0.33. And for the 5, it is 2.33. And for 6, it is it is negative 0.67. What we have to do, we have to find out the average of these three values, and that is the left side average. So left side average, you will get negative 0.66667. So that means it is negative 0.67. And then we have to find out the average of right side instances. So here these, you will get 0.67. Okay. Uh, now these are the predictions. Okay, these are the predictions. So if we consider these are the predictions, then we have to find out the SSR again, the sum of residual by 2. SSR by 2. Okay. So that means originally the value is this one, but the prediction is 0.67. So here is a negative 1.67 minus of negative 0.67. Okay, 67. square of that plus the next value is 0.33. Okay, so here is 0.33 minus of negative 0.67, negative 0.67, the square of that. Okay, so in this way we have to find out. In this way we have to find out the SSR by 2, and you will get the SSR by 2 5.33. Now what we have to do? Okay, this is place of living equal village. Then we have to consider some other uh, uh, splitter also. Okay, other splitter also. Like if we consider place of living equal place of living, so place of living equal city, equal city. The place of living equal city. This is the true side and this is the false side. The true side and false side. So now check the first one. First observation equal village. Place of living equal to city. No, it is village. So that means we will get the one in false side. One in false side. Then two observation two. Place of living equal city. Yes. So two will be in true side. And then three, it is village. So village is it city? No. So village, the three will be here in false side. And four is also village. Four will be in false side. And then five is city. So city will be in true side. And then six is city. That will also be in our true side. Okay. So this can be another splitter here, but we can see that actually these splitters are the same, because this is just a mirror of one another. Whatever we got in true side, we got in false side here in our previous tree. And whatever it is observed in our false side, that is 1, 3, 4, that we got in our the true side of the previous tree. So that's why it's called the mirror. Okay, mirror tree. So if this one is a mirror tree, no need to compute the that is the SSR again, because we will get the same SSR. Okay, so no need to consider the mirror splitter. So here this is the mirror splitter. So we have no need to consider this. Okay, so that means the one splitter is possible in this case, and we have already considered that, and we have computed the error, that is SSR by 2, that is 5.33. Okay, now what we have to do? We have to compare the error we received from place of living, and that is 5.33, and the minimum error we have received from our edge. The error received from our edge, that one is 3.67, and error from place of living we got, that is 5.33. Okay, so previously it was 3.67. This one is from our edge, and from the place of living we got 5.33. Then which one is minimum? We can see this one is minimum. So this one in this by the age less than 21. So here is this. There is age less than 21. So that means in our gradient boosting regression, we have to construct the gradient boosting regressor. There is one kind of tree, and on that case, on that case, the root of that tree will be age less than 21. Okay, age less than 21. So that will be our root of the regression tree. That is the gradient boosting or the gradient boosting regression. And if this is true, so this is yes, and if this is false, okay, so this is no. And we can see the left side instances. There is, we can see this is the left side, the right side, and the left side instances prediction is negative 1.03, 1.00003333, and for the right side the prediction is 0.99999. So here is negative 1.00003. Okay, and this one is 0.99999, like this. So this is the prediction for left side. This is the prediction for right side. We can think about like the uh, here you can see the for the 21 it is negative 1.00 and negative this one. It is roughly negative one and just positive one. Okay, roughly this one. We can use the same the actual value also. So negative one and here is the positive one. Now what we have to do? We have to build the model. Okay, now we have to build the model. And what's the model here? The f of x, that is f of x plus of h of x, So this is our h of x, and f of x is our initialization. That is the base. We have done the average for that, and this is the average. Okay, so that means it is 2.67, and plus of here is the h of x. Okay, h of x. But we know that we can incorporate the learning rate rho. So rho can be any values, or we can consider rho equal 1, but that is not practical. Okay, so we can consider the rho here. Maybe you can consider rho is like 0.1 or something. Okay, rho, and then this model. So what we have to do now? So this is the model. We build the model. The model f of x plus h of x. So f of x is 2.67, and we know that value. And then the learning rate we can consider maybe the 1, the 0.1, and times our model, that is h of x. H of x we build from the errors. Okay, so what will be the predictions, the new predictions? Okay, now we can see that is the if we pass our first observation to this model, first observation, then the age is 8, place of living is village. So in this case, it will be 2.67 plus the rho is 0.1 times. Then the age is 8. Okay, it will check the age. So age is 8. 8 less than 21. Is it true? Yes, true. So that means it will move in this direction. So here is the negative one. So that means here is the negative one. So if we compute that, then it is actually 2.67 minus 0.1. That is 2.57. 2.57. And we can see that the predicted IQ score on that case, that is 2.57 for the first case. Okay, 2.57. Then pass the second query, second instance here, and it is we can see it will be 2.67 plus of 0.1 times the age is 10. 10 less than 21. Is it true? Yes, true. So it will move in this direction. And here is the negative one. That means the negative one will be here. And then it will be 26.67, 2.67 minus of 0.1. So it will be 2.57, 2.57. Okay. Similarly, if we pass the third observation, then here is also 12, and that means that is also less than 21. So it will be the same, 2.57. Here is we can see 2.57, 2.57. Okay, the same. First three will be the same. Then if we pass the next one, that is 4, and age is 30, on that case it will be 2.67 plus 0.1, and then we will check the 30 whether 30 is less than 21 or not. This is false, so we have to move in this direction, and then we will get 1. So that means 0.1 times 1. So what we will get is 2.67 plus 0.1. It means it is 2.77. So here is this, we can see it is 2.76666 or 77. Okay, 2.77. Similarly, for the case of the S3560 also we will get that is the same value. Okay, 2.77. Okay, so that means that we utilizing our new model, we have now the prediction. Okay, we have now the prediction. Utilizing our new model, we have the prediction. Okay, so 2.77 like this way. Okay, now what should we do? The next thing is, these are our predicted value now. Previously, the average, that was our prediction, but now this is our prediction. This is our prediction, and we can see still we have some error, and we need to find out the errors also here. Errors from here. And how can we determine the error? The errors, the original IQ score. So those are the original IQ score, and these are our predictions. So we can find out the error or pseudo residual. It will be 1 minus this value, predicted IQ score 2.6, 2 point. First one is 2.56 or 57. Okay. Then we will get what? We will get the negative 1.57. Okay. So here is this negative 1.57. So in this way, we can calculate the error, that is pseudo residuals. The pseudo residual. So now we got the pseudo residuals again. The pseudo residual again because yeah, that is the model we developed. That one is also not perfect. Okay, so that's why we got the errors. So these are the errors. Now what we have to do, considering these errors, we have to create the data set again. That is A's place of living and the errors. So that means we can see this is the data set, new data set we have. The A's place of living and pseudo residual 2. Okay, the errors we got after our model. And again, we have to consider like building another model, because if we consider that previous one is our h of x, and that is not perfect, so we can consider this one is our h1 of x. So now we want to build h2 of x. Okay, h2 of x. So another model we want to build. There is another weak classifier we want to build, and for that, this is our data set. And again, we have the a's, we have the place of living, so we have to apply the same procedure. Like we have to sort the data based on the a's in ascending order. Then we have to find out the that is average of two consecutive numbers, like here 9 and 11, like this way. And then each and every average we have to consider as the splitter and find out the errors. Okay. So here is 9 as the splitter. On that case, average peer-2 score of left side instance, the average, and average peer-2 score of right side instance, this, and you will get the SSR by 2 is 4.624, like this way. So again, considering this data set, splitter ato, okay, so that will be our averages. Okay, so if we consider our averages, the splitters, if we consider those splitters and then find out the sum of square residuals by 2, then we will get those. And now again, what we have to do, we have to find out the lowest error. So lowest error we can see again we got from 3.66. Okay, 3.66. So that is our lowest error, and that means S21 if we consider S, then S21 will be the best splitter. But again, we have to think about our another feature, that is place of living, and we have to here the place of living. We have to consider this one as a splitter, and then we can see that is the errors we got from here is 4.89. Okay, 4.89. So if we compare between these two, is 3.67 and place of living is 4.89, then 3.67 will be the winner. So again, we have to think about the S uh, less than 21, another weak learner. Okay, another weak learner. S21 again. And this time we can see, this time we have the left side, we have the 0.9, negative 0.9, and right side we have in positive 0.9. Okay. Now we can see here again, this is negative 0.9 and positive 0.9. And previously we have this is our h1 of x, h1 of x, and this one is our h2 of x, h2 of x. Okay, and our learning rate is 0.1, and here's the 0.1, and this is our f of x, f of x. So now our model will be f of x plus rho, that is learning rate, times h1 of x plus rho plus h2 of x. Okay, so considering this model again, we have to find out our pseudo residual values. Okay, so now the predicted IQ score here, you can see, considering our this model, so if we pass the first observation one, age is 8, place of living is village, then it will be 2.67 plus the learning rate is zero point 0.1, and age is 8, so 8 less than 21. Is it true? Yes, true. So yes, true. Then we have to move in this direction. It is negative 1 plus, then learning rate is zero point 0.1 times, and then age is 8. 8 less than 21. Yes, 21. So we have to move in this direction. Then it will be negative 0.9. So if we do the math, then we will get the value here. Negative, 2.47. Okay, 2.47. So similarly, we have to find out the predicted IQ score for other observations also. And after that, after finding out the pseudo residual, what we have to do? Predicted score. What we have to do? We have to find out the pseudo residual 3. Okay, that means you can see that is original value minus the predicted IQ score. So 1 minus 2.47 will be negative 1.47. In this way, we have to find out the pseudo residual 3. Okay, so this will be our pseudo residual 3. And then we can see there is the next, what we have to do. We have to consider this one as our new data set. Okay, so A is place of living and pseudo residual 3. So from here we will get another, that is H, that is H3 of X. H3 of, when to stop? So the first stopping criteria is there is the number of iterations. Okay, or you can say number of weak classifiers you want to build. So if you want to build maybe 1000 weak classifier, then the iteration will be 1000. But if you consider about maybe 100 split, 100 weak classifier, then you can iterate up to 100. So another stopping criteria is our that is error. We can see the pseudo residual. So those are the errors we have. So if we can set an error threshold, like errors for all these instances, it will be less than maybe 0.001. So that is the error, the absolute value of error threshold. Okay, so this is absolute of error. It is less than this one. So our threshold is this one. Okay. and you can maybe continue infinite loop. Then based on the threshold, you can also stop the gradient boosting algorithm. So until convergence, it means until the rate the that is the accuracy you want, you can continue the loop and construct the number of required splitters or number of required weak learners. And every time it will be in additive way. Okay, this model is additive, and this is how we can find out. We can build the gradient boosting regressor. So any question from your side? So that is the explanation of this algorithm. Any question from your side?
স্যার আমার একটা কোশ্চেন ছিল।
হ্যাঁ বলেন।
স্যার হচ্ছে মানে রিগ্রেশন ট্রির হচ্ছে নিউমেরিক ভ্যালুর ক্ষেত্রে স্যার হচ্ছে মানে প্রথমে স্যার আমাদের হচ্ছে মিন ভ্যালু বের করতে হয়। মিন ভ্যালু বের করার পরে স্যার হচ্ছে তারপরে মানে আমরা যে ট্রিটা তৈরি করি ট্রু ফলস তৈরি করে তারপরে যে ডিসিশনটা ইয়েস অর নো দুইভাবে বিভক্ত করে দিই। স্যার এইভাবে করে প্রতিটা বের করার পরে তো হচ্ছে মানে প্রতিটা রিডাকশন বের করতে হয়। তারপর হাইয়েস্ট যেটা রিডাকশন হয় ওইটাই তো হচ্ছে স্যার রুট ট্রি হয় না? কিন্তু স্যার রুট ট্রি হওয়ার পরে স্যার আমার তো হচ্ছে মাল্টিপল ডিসিশন আছে। ধরেন আমি টেম্পারেচারের ক্ষেত্রে যে টেম্পারেচার 20 লেস দ্যান অর ইকুয়াল এইটা যদি আমি রুট ট্রি ধরি এটার ক্ষেত্রে তো স্যার আমার এক সাইডে 2টা ইয়েস আসলো নো আসলো আর এক সাইডে 3টা ইয়েস একটা নো আসলো। স্যার এটা আমি ডিরেক্ট কিভাবে হচ্ছে মানে এইভাবে কি স্যার মাল্টিপল ডিসিশন তো রুট দেওয়া যাবে না ট্রিতে?
আচ্ছা, এখানে আমি একটা জিনিস বলে রাখি, সেটা হচ্ছে আমি এখানে যখন কনস্ট্রাকশন করছি ট্রিটা, এই ট্রির ক্ষেত্রে আমরা এটাকে ওই অ্যাডাবুস্টের মতোই দ্যাট ইজ কাইন্ড অফ স্ট্রং কনস্ট্রাকশন করছি, ঠিক না? এটার ক্ষেত্রে
মানে স্যার
বারবারই
আমি
যে দেখো
মেজরিটিটা ধরে
একটা
হচ্ছে
রুট একটা রুট আর মাত্র দুটা লিফ, তাই না?
হ্যাঁ
বারবারই তাই করছি। এটা কিন্তু আলটিমেটলি স্টাম্প যেটা, এটাতে ম্যান্ডেটরি না যে স্টাম্পে হতে হবে, নট নেসেসারি, কারণ এটাকে আমরা একটা ফুল ট্রিও তৈরি করতে পারতাম, মানে এদিকে আরো হচ্ছে এক্সপানশন করতে পারতাম আমরা, ঠিক আছে? তাহলে এটা এক্সপানশন গ্রেডিয়েন্ট বুস্টিং এ এটা এক্সপানশন করা যেটা সেটা ভ্যালিড, এটা ইনভ্যালিড না, এক্সপানশন
কানেকশন
ভ্যালিড। হ্যাঁ, দ্যাট মিন্স এখানে স্টাম্প না, গ্রেডিয়েন্ট বুস্টিং এ কিন্তু স্টাম্প কনস্ট্রাকশন করে না, গ্রেডিয়েন্ট বুস্টিং এ ট্রি কনস্ট্রাকশন করে। আমরা যেভাবে র্যান্ডম ফরেস্টে হচ্ছে ট্রি কনস্ট্রাকশন করছি, ওরকম ট্রি কনস্ট্রাকশন করা হয়। আচ্ছা, সিম্পলিসিটির কারণে আমি জাস্ট চিন্তা করছি, মানে বলছি যে ঠিক
স্যার
আছে
ওই যে
স্টাম্প
স্টামের
অর
ক্ষেত্রে
ডেপথ
তো আমি
1।
মেজরিটি যেটা আছে ওইটাই হচ্ছে ডিসিশন হিসেবে ধরি।
হ্যাঁ
ওইরকম করে
হ্যাঁ,
করব।
ঠিক আছে। হ্যাঁ, এরকম করে। কিন্তু এখন যদি এরকম হয়, যেমন তুমি বলতেছিলে যে প্লেস অফ লিভিং এখানে হচ্ছে মাত্র দুটা আছে, দুটার চাইতে বেশিও তো থাকতে পারে, ঠিক না? যেমন তুমি টেম্পারেচারের কথা বলতেছিলা, টেম্পারেচার হট, মাইল্ড আর কুল, তিন তিন প্রকার হতে পারে, ঠিক না? এই তো কোশ্চেন ছিল নাকি?
জি স্যার।
হ্যাঁ। তো সেই
জি
ক্ষেত্রে
স্যার।
আমরা কিভাবে তাহলে ডিল করবো এটাকে? তো এখন এইখানে হচ্ছে আমাদের তখন ডিল করার জন্য আমাদের যেটা, সেটা হচ্ছে যদি থ্রি টাইপের হয়, যেমন আমরা এই এক্সাম্পলটাকে যদি ধরি যে হট, মাইল্ড আর কুল, থ্রি টাইপের টেম্পারেচার আছে থ্রি টাইপস। আচ্ছা, তাহলে কিভাবে আমরা স্প্লিটার গুলো তৈরি করব? তাহলে এখানে স্প্লিটার হবে তখন আলটিমেটলি আমাকে প্রথমে চিন্তা করতে হবে যে টেম্পারেচার ইকুয়াল
স্যার
যদি
হাইয়েস্ট
হার্ট চিন্তা
রিডাকশন
করি।
যেটা ওইটাই তো রুট হবে না হচ্ছে ইয়ে
হ্যাঁ, হাইস্ট যেটা সেটা রুট হবে অলওয়েজ। কিন্তু এখানে এই তিনটার ক্ষেত্রে আলটিমেটলি কোনটা কোনটা চিন্তা করতে হবে? একবার হচ্ছে টেম্পারেচার হার্ট, তাহলে এখানে ট্রু আর এখানে ফলস কেস, ঠিক আছে? তাহলে ট্রু সাইডে কি আসবে? এখানে হার্ট গুলো আসবে, যেখানে যাদের যাদের হার্ট টেম্পারেচার আছে যে ইনস্ট্যান্স গুলাতে সেটা। ফল সাইডে কি আসবে? ফল সাইডে আসবে এম আর সি, মাইল্ড এবং কুলের, ঠিক আছে? এটা
জি
একটা।
স্যার।
আবার আরেকটা স্প্লিটার আমাকে চিন্তা করতে হবে, সেটা হচ্ছে যে টেম্পারেচার যদি মাইল্ড হয়, তাহলে এখানেও ট্রু ফলস আসবে, ট্রু আর ফলস আসবে দুটো। ট্রুতে আসবে হচ্ছে মাইল্ড আর ফলস আসবে কি বাকি দুটা, বাকি আছে হার্ট এবং কুল। এবার আরেকটা কনসিডার করলে আমরা এখানে আছে টেম্পারেচার, কুল। তাহলে ট্রু অ্যান্ড ফলস হয়। কুলের ক্ষেত্রে ট্রু সাইডে কুল আসবে, আর ফলস এর ক্ষেত্রে হার্ট আর মাইল্ড আসবে। আচ্ছা, আমরা আর কি চিন্তা করতে পারি? আর চিন্তা করতে পারি আমরা আমরা টেম্পারেচার দুটো একসাথে চিন্তা করতে পারি। যেমন আহ এখানে হচ্ছে হার্ট আর মাইল্ড একসাথে, হার্ট আর মাইল্ড একসাথে। তাহলে এখানে ট্রু সাইড থাকবে আর ফলস সাইড থাকবে। ট্রু সাইডে আসবে হার্ট আর মাইল্ড, আর ফলস সাইডে আসবে কুল। আচ্ছা, আমরা দেখবো যে এখানে মিরর আছে কিনা। তো এখানে হচ্ছে আহ এক সাইডে এইচ এম আছে কিনা উপরে কোথাও। হ্যাঁ, এখানে এইচ এম আছে, ফল সাইডে আছে। আদার সাইডে সি আছে, আদার সাইডে সি আছে। তাহলে এটা এবং এটা আলটিমেটলি এরা হচ্ছে মেরর, এরা হচ্ছে মেরর। মেরর হলে এইটা কনসিডার করব না আমরা। ওকে, তাহলে এটা দিয়ে আলটিমেটলি আমাদের কাজ করব। হ্যাঁ, হ্যাঁ, ওকে, বোঝা গেছে?
স্যার আমার জি স্যার, আমার শুধু কনফিউশন ছিল যে মানে কনক্রিট ডিসিশন তৈরি করতে হয়তো স্যার মাল্টিপল এভাবে আসে, মানে আসে কিনা হট অ্যান্ড মাইল্ড দুইটা একসাথে, এইটাই আর কি।
হ্যাঁ, আসে, এরকম আসে। এখানে চারটা হলে আরো ভালো বোঝা যেত। এই চারটা যদি থাকে, যেমন হার্ট, মাইল্ড, কুল, এক্সট্রিম কুল, চারটা, এটাতে তখন দেখবে যে অনেক কম্বিনেশন করতে হবে তোমার। হট মাইল্ডকে একসাথে নিতে হবে, হট কুলকে একসাথে নিতে হবে, হট তারপর এটাকে একসাথে নিতে হবে, এক্সট্রিম কুলকে। টোটাল নাম্বার অফ ইন স্প্লিটার্স মেবি আমাকে চিন্তা করতে হয় 2 to the power n minus 1 minus 1। এখানে n যদি আমরা হচ্ছে n যদি হয় আমাদের 3, তাহলে কতটা আসে দেখো, 2 to the power n, n হচ্ছে 3, 3 minus 1 minus 1, তাহলে 2 to the power 2, that means স্কোয়ার minus 1, তাহলে এখানে হচ্ছে 4 minus 1, that means 3। তিনটা স্প্লিটার কনসিডার করতে হবে যদি n এর ভ্যালু 3 থাকে, মানে তিন টাইপের যদি হয় আর কি, হার্ট, মাইল্ড এন্ড কুল। তাহলে ইন্ডিভিজুয়াল তিনটা স্প্লিটার পাবো আমরা এরকম। যদি এরকম দুটো হয় তাহলে কি হবে, 2 to the power n minus 1, that means 2 to the power n minus 1 হচ্ছে n হচ্ছে 2, 2 minus 1 হচ্ছে 2 minus 1। তাহলে ইন্ডিভিজুয়াল একটা স্প্লিটার এনাফ হবে আমাদের। যদি আমাদের চারটা হয়, যেমন এখানে দেখাইছি এইচ এম সি এন এসি, তাহলে 2 to the power 4 minus 1, that means 3, 3 minus 1 স্প্লিটার হবে, তাহলে 8 minus 1 7টা স্প্লিটার হবে। ওকে, ঠিক আছে, তাহলে আর কোনো
ঠিক আছে
কোশ্চেন?
না স্যার, স্যার এর থেকে তো মনে হয় ওই যে স্ট্যাম্পের যেটা আর কি মানে আমরা করি হাইয়েস্ট ডিডাকশন নিয়ে, ওইটা মনে হয় বেশি ইজি হয়।
হ্যাঁ, হ্যাঁ, ইজি হয়।
রিলেটিভ যেটা ওইটা ধরে করে ফেললে আর কি বেশি ইজি, এটা তো অনেক বেশি লেন্দি প্রসেস হয়ে যায় স্যার।
হ্যাঁ, দেখা যাক।
ওকে
ওকে,
স্যার, থ্যাংক ইউ স্যার।
ওকে, থ্যাংক ইউ। আর কোনো কোশ্চেন না থাকলে আমরা শেষ করি। হ্যাঁ।
স্যার, এই আমাদের মিড টার্মের প্রিপারেশনের জন্য কিছু কোশ্চেন যদি স্যাম্পল কোশ্চেন যদি দিতেন প্র্যাকটিস করার জন্য উপকার হতো।
আচ্ছা, ঠিক আছে, আমি CSE711 মনে হয় দেয়া আছে, যদি না থাকে দেখো আর কি, ওখানে প্র্যাকটিস প্রবলেমস নামে একটা ফোল্ডার
স্যার
থাকার কথা।
খুঁজেছিলাম পাইনি, 710 পাইনি, 711 পাইনি স্যার।
আচ্ছা,
আচ্ছা,
ঠিক আছে, আমি একটু
সেভেন
দেখি।
ওয়ান 710 তো স্যার একটু দিয়েন। আমি আপনার ওই ডিসকর্ড গ্রুপে মেসেজ করছি, কিন্তু মেবি আপনি স্যার ওইখানে
আচ্ছা
মেসেজটা চেক করে না তো, তাই এখানে বললাম স্যার ওই
আচ্ছা
17
ঠিক
যে
আছে
পোস্টটা, ওই পোস্টটা একটু দিলে ভাই স্যার ভালো হতো খুব।
আচ্ছা ওকে নো প্রবলেম ইনশাআল্লাহ
স্যার থ্যাংক ইউ,
ঠিক
আসসালামু
আছে
আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম ভালো থাকো সবাই বাই